Hey everybody, welcome back. Savvis Algebra 2, working on lesson 7-6 trigonometry. And we've got problem 7 that I've asked you to work on. So this one has several parts to it, 6 parts. Let's get right to it. Starting off with the first thing says, what's your amplitude? So that's pretty straightforward. Your amplitude is just your coefficient out here in front of the whole thing. So let's put that in there. This problem toward the end gets a little bit tricky when you get up there toward the 5th and 6th part. So let's get moving. The next part says, what's the range? So this range, reminder of what we've been talking about when we've been doing those. Your midline's moved up to 2, so it's oscillating back and forth across that line. And then your amplitude above and below that, you've got an amplitude here of your 4. So this one goes 4 higher and 4 lower than that. And so those numbers for that, if you go, there's my 2, and you go up 4 would be 6. And you go down 4 from there, that would be down to a -2. So those would be my range. So when I come over here and I need to put my range in there for that, that's gonna, and they want interval notation there. So interval notation reminder, it actually hits the lowest point, -2, and goes up to the highest point, 6, for this problem. Continuing on, the period. So reminder how the period goes here. It's for sine and cosine, it normally will complete a period in 2 pi, but this frequency says how many of the cycles are actually completed during that time, and 2 of them. So if you take the 2 pi, let's see, I color coded that there. That would be kind of nice. So this 2 right here, divided by that 2. So my period for this graph is just the pi. And I don't know if you've realized this yet, but Savvis will let you, instead of hitting the pi button, you can just type the letters pi. But let's see. And moving right on to part 4, this is all good. The phase shift. So phase shift is if you're moving it from left to right and transforming it that way here. So my phase shift on this, if you were to take this part right here and factor the 2 out, you have x minus, and then whatever I put here has to, when I distribute this 2 in, has to go back to a pi. So I'm saying 2 times something, and it equals pi. And so if I'm trying to solve for this like this were an x or variable, so I divide by 2, so it'd be like pi over 2, so that I solved for it. So that's going to be pi over 2, or if you think about it this way, 2 times, it's getting too messy there. Let's say, let me just put that pi over 2 right in here. Put that pi over 2 here. So when I multiply that 2 there, those would cancel, turning it back into the pi that it started with. So however you think through that process so that it makes sense in your mind, that's the right way to think of it. But those are a couple ways I see to think of it. So pi over 2, pi, well, let's see, let's put that pi up there, and 2 down here, and I'll get rid of that pi out in the front, and we should be good to go there. And now this part gets a little bit tricky. So here's where they want us to fill in all the key parts of our normal sine curve. So your normal sine curve, we're talking about sine, right? So sine, reminder, sine usually goes like that, with all your key points here being, you got your 0, 0 there. and then it finishes the cycle at 2 pi. Imagine that says 2 pi 0. And halfway in the middle, if we're talking about the unit cycle here. And so when we go around, sine being y, so y is 0 here when we're at starting. Then when we get all halfway around, that's pi radians, and we're up at 0. And we get all the way back to where we started, a full rotation. We've talked about that many times in the past. 2 pi, so y 2 pi radians is a full rotation of 360 degrees. Go back and look that up if you need a refresher on that. And then let's see, some of our other key points here, when we're right up here, halfway to pi, or halfway to this pi would be pi over 2 up there. And my y up there is the 1, the maximum it ever gets. And then down here, if I'm at halfway between pi and 2 pi, that's a 1.5, or usually written as 3 pi over 2. And that's down at -1. So for that point, right down there at what we might otherwise think of as 270 degrees. So that's what they have as the original quarter points of sine. And then remember what we have just said here. This minus pi over 2 is a phase shift of pi over 2 to the right. And then we also calculated that our period now, our period is only pi for this problem. So keep those two things in mind when we go to fill in this chart. I'm going to get this out so we can see what we have here. So we're using, this was the period. So for each of these points that we had right here, those key 5 points, that's what you see up here. And we're going to move those pi over 2 to the right, and then they are asking us, what are they when we get to the next cycle of the graph here, if you will. So move them pi over 2 to the right, and then take each one of them and add our pi or period onto that to find where they would be after we do those transformations. So in this case, these are pretty nice numbers, or nice ones to work with here. So if I took this pi over 2, or this 0, 0, and went 0, 0, I'm going to move it to the right pi over 2, which would get me to pi over 2, 0. And then I'm going to add the pi onto that point, which would give me 2 pi's over 2 added to the pi, will give me 3 pi over 2. And then the whole thing also was moved up, right? So the transformation of up to, so what we're doing here is the x value is gotta be added a pi over 2 to that, and the y value transformed up to, again, if you're looking at it going, where's he getting that from? Those are coming from my pi to the right when we factored it out and did this right here. I'm sorry, the pi over 2 to the right. Pi over 2 to the right, because for this, we took the 2 from here, factored it out, it would be 2x and then minus the pi over 2. So that was the pi over 2 to the right. And then this up to right here. So that's what I've done here so far. And then to get to the next cycle of the graph, we're going to add on to the period, so onto the x. Because our new period was this pi over 2, right? The new period, or no, the new period I think was pi. New period was pi when we took 2 pi, the regular period, and divided by this coefficient of the x, 2. So that's my period. So for each of these x's, we're going to add a pi over 2. The y is added 2. That'll get us moved up and over to where that point has been moved. And then for the next cycle of the graph, where it says the 5 quarter points, the corresponding of the next ones. Yeah, because the initial one will just move, but then these points are going to be affected by the new period. So let's see here. I have something here that happens slightly different yet too. So the first initial point, add pi over 2 on, skip my parentheses, pi over 2. And then get that 2 added on to the 0. And then the next one, we've got to do that same thing, but my period has been compressed down. So if my period's pressed down, that's going to move that point a little closer to this point also. So let's take that into consideration here when we get to the next point. All right, so then the next part of that, so we're going to have that. We've got all of those pieces of our graph. And so now we've said we were transforming that graph again. And we took the 0, 0 point. Again, when we factored out that 2, it was x minus pi over 2. So there's my pi over 2 to the right. So this is going to go pi over 2 to the right. That's pi over 2. And then it was going up 4. So this, it's vertically stretched by 4, which after we also moved it up this 2, up over here and up 2, I'm going to start from there, but then it's going to go as high as 6, we said. Lost my sketches here. So I was oscillating across there, going as high as there, moving over to here, and then so my new period also was the 2 pi over this 2 to get a period of pi. So if I've got that starting point right here, when we moved it from 0, 0, pi over 2 to the right, and then up 2. So, and we now got our new period of pi. So this period is going to end over here. If I'm at pi over 2, it's going to end right here. Well, this was pi over 2. If it ends when you add a pi onto it at the end of the period, what's 2 pi over 2 plus that 2? That would be at 3 pi over 2. So it's going to go up here, down to here, and it has to end the cycle right there. So if we do that, all right, that's going to be our last point of that one period of the graph. So down here, I'm going to end that cycle at 3 pi over 2, a whole pi plus a half a pi. So 3 pi over 2. And then my y value up at that 2. All right. And then we're halfway in between there. Where we're going to if we start the cycle here, we end the cycle here, halfway in between, we have to be at that point, and the whole period was pi. So at that point, we'd be at like a half a pi. So if you add on to that point, which was pi over 2, to get to this point, another half a pi over 2, that would be at pi. So then we're at pi 2 for that middle point. Pi 2, pi over, but the pi, oops, pi, comma 2. And then where would we be if we were halfway in between those? So if I'm halfway in between those, I'm halfway in between these 2 points, so I get up to here. Remember that was pi over 2 and pi over 2 and pi. What's halfway in between there? That's a half a pi. That's a whole pi. What's halfway in between a half and a whole? 3 pi over 4. So 3 pi over 4 right up here and up at that 6 point. And we do sort of that same thing down here. What's halfway between the whole pi and a pi and a half? A whole pi and a pi and a half. So if you have a whole pi and a 1 1/2 pies, right in between here would be 1 1/4 pies, right? 1 1/4 is halfway in between those two. So that would give me 5/4 pi, or 5 pi over 4. And then that's down at -2. So the point for down there. Now I'll show you one other way you could also get those same points. Hopefully they match up with what I've just said. Let's see, this one we said was at our 3 pi over 4, so parenthesis, 3 pi over 4. Oops, get that comma, arrow to the right, comma, and we were up at 6 on that point. And then for this point, we said we were at this 5 pi over 4 down at -2 for the symmetry. So the key to this problem, for me mentally anyway, was transform your starting point 0, 0 over and up. Then look at your period, how long it takes to get back to finishing your cycle. Go halfway in between. So that was like we were here, half period of pi got me to there. Go halfway in between there to find this point because all the y values there are the same. Then split the difference on these two to find up here. And same thing with these two to get the 5th point down there. So it took me a little while to get my mind wrapped around that, but hopefully that's kind of helping you on this problem. Also to see that, let's get this last one typed in here. 5 pi over 4 and a -2. All right, now before I go on and hit enter, we could also put these in here. So 4 sine 2x, that was my original problem here. If I wanted to turn on where's my normal sine graph, I can scoot this toolbar over. So I click here. That would have been right in there. And then we moved, there was my 0, 0. I moved that starting point here to the pi over 2, 2. And then if I look at my key points, so right up here, there's my 3 pi over 4, 6. That's what I put in, right? 3 pi over 4, 6. Also, where it came back and hit the pi 2, pi 2, pi 2. My low point down here, the symmetry, 5 pi over 4, -2. 5 pi over 4, -2. And then lastly, back to my midline at that, hard to read some of these, where I've got the 3 pi over 2, 2. So 3 pi over 2, 2. So I'm feeling pretty good when I put all those in and I graphed it. The other thing that I did down here is I graphed it using, let's take that one out, where I factored out this phase shift, the 2, so I could see the horizontal, the phase shift here, this frequency 2 out in front. But if you turn that on, it should be right on top of the red sinusoidal if I actually factored it all right. So turn that on, and if you notice, I'll turn it on and off again. And you can see it, yep, that did match up. So then that pi over 2 right and 2, that confirms that's correct too. So I think we should be good there. And taking us to our last one, which then has the graph that matches the one I just showed you here. Nice to just look at it there. So starting at the y-axis, going down and then up at the 2, that should probably be about enough for us to see it going down as low as the -2. This definitely looks like the only one that could be. So little long explanation there, but I want you to give you as much as you need to hopefully you can understand it and rewatch it or ask me questions if you need some help. I know this, if you stick with it, search out your solutions, you can do it. Keep after it. Have a great day, everybody.